Welcome to the most requested video on the Null channel. So I know that a lot of you have been asking for Kubeflow pipelines, and it's finally here. The day has arrived. Kubeflow pipelines will be explored. Now, I hate to burst your bubbles. I have decided to actually break this up into a couple of videos for sanity's sake on my part and for ingestibility on your part. It turns out that Kubeflow pipelines are actually kind of a big subject to talk about and cover. And because of that, I wanted to break it up into manageable chunks. So today we're going to do Kubeflow pipelines the easy way. Let's get into it.
The Null channel.
All right, so you've heard me say that every step in a Kubeflow pipeline is a container. And in theory, that means that every step requires its own special container that you need to build out and host in a container registry somewhere. And the correct way for reusable components is to do something similar, something like that. But if you're just prototyping, there's two alternatives to making a pipeline or a container for every step in your pipeline. And we're going to explore those today to get you off the ground playing with pipelines. And then in some later ones, we're going to explore how the best practices for some of these reusable containers are. So let's start at the very beginning. Basically, Kubeflow Pipelines has two sides. The first side is the UI that we can go over here and see. Cannot type tonight. All right. Oh, 10.50, not 10.10, 10.50. All right. So this is my home Kubeflow server. And we can go over to pipelines here and we can see all of our pipelines. So there is this one here. You can click on it and you can see this really nice graph of your pipeline. And like I said, each one of these that we can click on here is a container itself. And you can see what arguments are passed in, what outputs are expected, and the command given to that container. And so each one of these represents a container. All right. And we can see our whole graph here. And so this is the part of the pipeline that you interact with as what I'm going to call an end user. All right. And you can look at the YAML for that. And here you can upload a new version. So if you had a new version of your pipeline that you wanted to upload, you can upload a version of it from a file or a URL. And this is really helpful and really nice. Now, the other side of Kubeflow pipelines is the actual creating the pipelines, and they have a library to help you do this. Now, if you're not very familiar with Python, it's all built around Python, and it's really helpful if you have good Python knowledge. I think because a lot of machine learning is based around Python, and let me know if this is something you'd like. I've been wanting to do a intro into computer programming and doing some actual programming because I like to program as well. And I was either thinking about doing it in Rust or Python, and I probably will end up eventually covering both languages. But I wanted to know what you guys want, if that would be interesting to you. Anyways, you need to know Python. And if you're interested in machine learning, you probably know Python anyways. All right, so this is the end user, but we want to look at actually making our own pipeline, and we don't want to make containers. Let me just throw that out there. And so I made this pipeline called cheating because it cheats. It doesn't actually, we don't maintain, we don't use any Docker files to build a pipeline. We cheat. All right, but you can see I've made a pipeline here that does legitimate things and can have legitimate outputs, and we can run instances of these. So you can look at the experiments here, and you can see that I ran this here. Let's delete these here. Ugh. There we go. So you can see that I actually ran it here and it did things. All right. So this pipeline, I didn't create one container for. So let's go look at how we're going to create a pipeline and talk about some of the components of this pipeline. So basically, there's two components to a pipeline. There are the containers, and then there's the file that defines the pipeline and how everything is tied together and works together. So in this cheating example, we don't have containers. We only have the file that defines the pipeline, and it makes it a lot more simple. And you can actually use this technique for quick iterative testing. Now, I think in a production pipeline, you don't really want these because they're a little harder to debug and they're a little breaking outside the norm. So I don't necessarily recommend you use this for a production pipeline, but it is a fast and effective way to create a new stopgap and to test something out. So it's really effective in that regard. So let's go ahead and look at this cheating pipeline. We're going to cd into containerless. All right. And here we have this cheating containerless.py. This is what I named it. I'm actually really bad at naming, and a lot of our job is naming stuff. So I guess I'm really bad at my job. Let's look at this Python. So this is the basic bare bones of a Kubeflow pipeline. It's not very big. Let's look at what we have here. It's not a whole lot. Now, what we did here is we used standard containers. That's all we did. And passed the arguments we wanted. So if you want to look here, each one of these does have a container. This one is based off of the Python Alpine build. This one is library bash and another Python. So this is why I consider it cheating, is we are using containers and each step is its own container. We're just using pre-built, already made ones and passing Python scripts into it. And this is why I don't consider this maintainable. One of the reasons I don't like Python is how hard it is. Anyways, we don't need to get into that. This is not ever a good production thing to do. You'll see it in production, don't get me wrong. And I've written stuff like this that's in production, probably still today. But this is not a great way of doing production. But you can see we have our container here, we have our command, and we have our arguments that we're passing to our command. And we even we state that we have a file output. So not only this, our container produces output, and then we use that output in following commands. Now let's change this so that we can make a new version of the file. We're going to go here and we're going to say this is going to be let's see. Let's just do this, my item. So it's going to print the item. All right. So we'll see this take effect when we upload the new version. And that's a really cool thing about the pipelines is you can track across versions of your pipelines and see how they're performing. But let's go ahead and talk a little bit more about everything that's in here. So we looked at these different container images, and that's good. But there's actually a lot more going on here. So first, you can see that we're importing something called the DSL, and we'll talk a little bit more about the DSL, but KFP is the Kubeflow Pipelines. That's the project. And there's some other things other than just DSL that you can, and this is where really I'm probably gonna make a whole lot of videos on doing some really fun and crazy things with Kubeflow Pipelines. My whole goal is to actually get a public Kubeflow instance out there running that people can see. I'm still working on how I can do that safely and securely, but that people can see and maybe even experiment with. So hopefully I can get that done. Here we're going to look at this. So this is how we're defining that it's a pipeline, and we're giving it a name, my pipeline. We can change its name if we like. It's right here. All right. And we're defining a pipeline. So your pipeline has to inherit from DSL.pipeline. End of story. And it has to have a name. End of story. All right. Next that we're going to look at here is these commands here. This is a container operation right here. This is how you're going to chain stuff together. And if you notice here, we are depending on the output from operation 1. So this is how we're chaining together an operation. We're saying that this container op depends on the output of the first one. So does this one here. But if you notice, all of these, this is a DSL parallel for, none of these depend on each other. So it's going to spin up one of these container ops for each one of the outputs here. So you're going to get, well, I mean, you should know exactly how many you're going to get because this is not a random number. You're going to get 10. And so you're going to get 10 of these. So we can actually change this. This is easy to change. Let's change this to 25, 26. All right. So now we've changed the number that's going to run. There's not going to be as many. So this is something, this can be dynamic in nature. So you can do these dynamic sort of number of runs or things like that based off of what's happening in the pipeline itself. You can get overly tricky and screw yourself up here. I'm not necessarily saying that you should always do that, but you can. So these don't depend on each other to run. They can all run at the exact same time and will run at the exact same time later on. So you can see that. All right. And then this last one, it just takes the output file and it prints the sum. So, well, it does two things. First, it prints the array here. This kind of got screwed up. This doesn't even make sense. Echo output 0. Let's actually name this up here something different. My output cup 0. Let's do this. Gen numbers. All right, so that's going to call it be gen numbers and output gen numbers. All right, so this is just going to print out the output of that, and then it's going to run a Python script to print the sum of everything in that list. And that's all we're doing here. All right, and then you notice here, we are giving it the KFP compiler and to compile it and making this YAML file right here. And that's the YAML file when you open it up in the Kubeflow pipeline that you can see there. So I'd like to take a quick moment to move on. All right, so this is the anatomy of a very, very simple Kubeflow pipeline. Now, there's some more things that we can do. We can make more or different functions in and reuse them. And we're going to get onto reusable pipelines in the future. But I wanted to make sure that I got a video out and that it covered the basics of Kubeflow pipelines so you guys could start to play around with them. You could use very simply any container out there that had like TensorFlow and train a model. And there's some examples out there on how you might do some of those. So don't get weighted down in thinking, now I'm going to have to create 100 different containers and I'm going to have to create all the Docker files. That is a lot of work. And while if you're supporting a production pipeline, that might be needed. But if you're a hobbyist, you don't have to wait for that. And if you're starting to ramp this up at work and you need to prototype stuff, you also don't have to prototype using finished pipelines. All right, let's write our changes. Now you'll notice there's a problem here. When you go to Kubeflow, let's go to Kubeflow here and let's go experiments and not pipelines. And let's go upload pipeline. We're going to go here and upload a version. If you notice here, you can give it a file or URL. We're going to give it a file. The URL is really what you want to use in a production scenario so that you have this continuous, but we're going to use a file. If you notice what it's looking for, it doesn't want any old file, and it doesn't want the .py that we have. We have a .py, but it doesn't want a .py file. It wants a zip file or a tar file. How do we get? And it doesn't want you just to take that .py file and to tar it, so don't do that either. You actually have to use the DSL compiler. So let's go do that. So we can go and find it right now. Let's see. Home. Oh, it's silly snaps. I really hate when snaps do this. All right. Let's see. We want to go to code. Oh, well, code would. Alphabetical order confuses me all the time. What order that is just like, whatever. All right, Kubeflow Pipelines examples, containerless, and you see that it wants this. If you're going to try to upload this, it shouldn't work. Let's try. Yeah. Invalid input error. Unexpected pipeline file format. Support .zip, .trg, .gz, or YAML. So I actually really like the YAML files. So if you really wanted to do just YAML, I think that that's a really good way. But the tar.gz is really easy as well. And so we're going to do that today. And maybe we'll explore using the YAML files a little bit later. So let's go ahead and dismiss this error. How do we get the file that we need? The file that this is expecting. All right, so to do this, you use the DSL compile. Soak it in. All right, so now that you've soaked in this glory, we can check out its help. DSL compile isn't found. I just remembered that for this, we're going to install it all. So you get to see all of that fun and all of that. So the best way with Python, if you're new to Python, you want to set up a virtual environment. 100%, without a doubt, virtual environment it is. I'm going to use Miniconda, and one of the reasons I'm using Miniconda isn't anything super specific other than it's what Kubeflow documentation and everything uses. So in the interest of keeping everything in sync, I'm using Miniconda. You should be able to use anything you want. Yeah, you should be able to use anything you want. Any virtual environment for Python that you'd like. So don't take this as you have to go switch to Miniconda. I'm just using it because that's what upstream Kubeflow uses. Go ahead and initialize it. All right, so All right, and presto, we've now installed Miniconda. All right, so with Miniconda installed, we want to create a 3.7 Python version virtual environment. So that's what we're going to do. We're going to conda create name ML pipeline. You can name it whatever you want. Python 3.7. Now, this is why I like this Zhush theme. So now we can do conda activate ML pipeline, and we're in our mini conda. Oh, conda init Zhush. All right, so let's get out of our shell. Let's open it back up. All right, this is why I like this Zhush theme so much. Right now, you can see, and if you go back to conda activate ML pipeline, you can tell we're on the ML pipeline. So not only that, if you type in kubectl, it tells you which Kubernetes cluster that you are going to be doing a command against. So a command line, a theme that gives you this much information is so useful, especially if you're accustomed to dealing with multiple Python virtual environments, or really more likely also multiple Kubernetes instances. This gives you so much information and so much knowledge right there with what you're working with. So anyways, I highly recommend it. It's very nice. So let's get back into it. It is also pretty. It's not about being pretty though. I don't know. It's a little bit about pretty. I like pretty terminals. All right, let's go on. Nobody cares about pretty terminals. So let's go code, Kubeflow pipeline examples, and containerless. All right, so we're back in here and we see this. So now we need to install the DSL. You notice we're in our ML pipeline, so we're installing it in that. All right, so we're just installing it in our ML pipeline. That way we don't mess up the rest of our environment. Python is a little messy sometimes. Messy is a good word. It can be messy. It's important to have a virtual environment. That's all I'm trying to stress here. This isn't a Python tutorial. Have a virtual environment. All right, cool. And so now we need to vim and then you're going to want to source your path or your profile. All right, so now we should be able to do DSL compile. And boom, we've now installed the Kubeflow pipeline tools. All right, sweet. Now we really want to compile our Python. So let's do DSL compile. And you're going to see some pretty good documentation here. So this is what we're going to use today, the absolute path to a Py file. It's easy, it's straightforward. This is another tutorial for another day with a package. This is actually really cool. You can make it based off of a function. All right, so you can, so basically this is all different ways you can use the same thing and do the same thing, whether it's a Python package, whether it's a function, whether it's a file. We're going to do the file today. And then basically disable type trap and telemetry. You probably shouldn't do that, but so let's do it. It's very easy. All you have to do is, here's our Python file. So we're going to do DSL compile. We're going to do --py. And we're going to do cheating containerless. All right. And now we're going to output. What should we output? Let's do cheating. Just because this is what I did the last one. Let's do output cheating.tar.gz. And there we have it. You've created your first Kubeflow pipeline. Let's go upload it and see the changes take effect. If you remember, we changed the name of one of the steps and we reduced the number of experiments that would happen, the number of branches that would happen in parallel. So let's go and check this out and see, upload a new version and see how it changes the pipeline's behavior. So now we can do this and we can say upload a new one, and we have a tar.gz. We're going to open it and click create. Now you notice it has a new name, Gen Numbers. That's a much better name. It's much more descriptive. And we have our for loop still here and our total still here. All right. This is really not hard. And let's create a run. So to create a run of a pipeline, you can go here and create a run. So basically there's two ways to run them. One is to create a reoccurring run, and one is to just create a one-off run. So most of the time you want these reoccurring runs. This is a great way to manage and keep a pipeline up to date, especially if you're always bringing in new information to train it with or things like that. So your data that you're using to train the pipeline doesn't necessarily change. So you could have it train every single day, or you could have it train once a week when you do it. So let's go and create a run of this pipeline. We're going to call it cheating. Looks good. Looks good. You need to choose an experiment. We're just going to use the default to use this experiment. And it's a one-off. So we could do a reoccurring and do it on a periodic or a cron job. There's a lot of different ways that you can set this up. A lot of different ways. There's really two, periodic or cron. So whatever fits your needs at that time. But we're only going to do a one-off because that's what we want to see our pipeline. And most of the time, this is probably going to work just fine if you're making iterations on a pipeline, experimenting. It's going to work just fine. Now, you could do reoccurring and, just wait for it, but I like the one-off for that. All right, so we're going to start it, and you're going to notice it has this unknown status. It's running a new version. So this was our first version. It ran in 16 seconds. So it's probably going to be done. Yeah, it's already done. All right, now you'll notice in this run, we have much fewer items because we decreased that list. So basically the whole point of this was to prove that we created a new pipeline, not that we did anything super useful in this pipeline, just that we created a new pipeline. It has a new name, Gen Numbers. The logs will have fewer items, or the output will have fewer items, about half. And here we have our one that prints the total output. So you can see these are where the numbers selected, and this was the total output of all those numbers added together. So we did all of this quickly and easily without actually creating a container. And that is Kubeflow Pipelines. Now, we will be getting into more on the different features. If you go back here, let's look at this. I very quickly brushed over like the different DSL things we used container op and parallel for. So, this is basically your for loop. And so it parallelizes a bunch of different tasks. And then you could actually bring them together down here inside of this if you liked. And there's mechanisms for that. There's different mechanisms for recursion in a DSL. So you can do recursion The container op is your base line. It's run this container with this input and yeah. And so here we're producing an output. So when we do this dot output, it knows that we're talking about this file that we created. We gave it a name, image, and the command and arguments. This is the basis of your Kubeflow pipelines. And this file, if you want to take it and use it and make something off of it, this file itself is based off of one of the upstream files. So go ahead and look at that. And look at some of the other upstream ones. I hope that some of this has clarified some to you. Now, there is yet another way to create a Kubeflow pipeline without containers. Now, this one I'm a little less familiar with, and you're going to have to forgive me if this section is a little rough, but you can create one inside a Jupyter notebook. So let's do that. I have a Jupyter Notebook server up and running. So we have this one right here. Let's connect to it. It is nothing special. It is a CPU TensorFlow 2.0 notebook server, and it contains my examples. 4 CPUs, 8 gigs of memory. Let's upload the example lightweight. All right. So upload. Unexpected token in JSON at position for what? How? Let's go look at that. And this is why I don't like Jupyter notebooks. Actually, I dislike them for a lot of reasons. I really don't like Jupyter notebooks. I wish Jupyter notebooks would go to a YAML and Python, just pure Python, pure YAML. I think that would be a whole lot better. This is gross. Let's move on. This is not about why I hate Jupyter notebook. What was its complaint? What was it? Let's try uploading it again. I shouldn't have gotten rid of its complaint. Unexpected token in JSON at position. I don't even know that we're going to be able to do. Boom. Upstream. Lightweight. IPYNB. All right. I just took that straight from the upstream. We'll manipulate it. We'll do some stuff. We'll play around with it. But hopefully that works. All right. So let's look at what this is. Hopefully this is something. Hopefully we can upload this. Upstream lightweight. Open. Upload. And it works! Never trust me to make a Jupyter notebook. It seems that Jupyter notebooks hate me as much as I hate them. All right. So this is the upstream's lightweight Python components. I had done a few things, and when I commit this, I'll have my things in there. But let's talk about what this is going to do. Basically, this is going to give you a Kubeflow pipeline in your Jupyter notebook. Now, because of this, it actually needs to run in your Kubeflow. You can't just run this from any Jupyter notebook. And I say that, caveat, asterisk, you can actually run it in a disconnected Jupyter notebook that can point to a cube, but that's a lot harder and it has problems. And we're not going to do that today. For today's example, run it in the Kubeflow, a Kubeflow Jupyter notebook server. All right, so here we're just importing the same things that you saw in that Python file. Here we're defining a function to add. And here we're using this right here, the components, function to a container. So basically, they're making this. Now, what you have to understand is this is very much the same cheating that we did in the last one. And by that, I mean that when you're doing this, you basically have access to Python and a few other things. It's not a full environment and you can't do everything that you would expect to be able to do because the container that this is based on, when it says function to container OP, the container that it's building is just one of those pre-packaged containers that they're slapping your function in. All right. So if your container needs special things, special entry points or whatnot in their function, you can't do it. And even if you wanted to have another function called that maybe is called 3 or 4 times, you'd actually need to define that function inside of this function, or else it's not going to work. So be careful when you're doing this. There's a few weird caveats that you wouldn't expect. All right, so we're building a container based off of this function. All right, now this is the next thing that they're doing here is doing a slightly more advanced with inputs and outputs. Actually, just inputs. Oh yeah, and outputs. I was gonna say mine had outputs. Come on, outputs. All right. So from here, you're going to see that they're defining one here and importing some stuff. These are all fine to import. You're also going to see that they define functions inside of their function that they're going to export here. All right. And here they're also doing outputs. So I highly recommend you look through this. I can go through and talk about everything that they're doing, but it's really pretty standard Python stuff. And so if you need help with the Python, let me know. We'll do a whole series. I want to do some algorithms anyways, because algorithms are fun and interesting. So we'll be doing those, but let me know if you actually need it, because that will bump it up on my list, because it's not very high on my list right now. But yeah, you can see kind of just how they're dumping these into JSON files. So they're taking these metrics that they're building and putting it into a JSON file as an output. So this is a lightweight container because it's using a pre-built container and basically putting your function in that pre-built container. All right, and then you can test running the Python function directly. So you're just calling it. And here we're converting the container, the function to a container. And we're giving it a base image of the TensorFlow. So again, this is telling it which image is the base image to run your function in. Now is the really cool part, because we actually want to run this pipeline, and you can actually put this in your Jupyter Notebook file to create the pipeline for you in your Kubeflow server. 1 second, I have to make sure I'm not out of time. I didn't have that much time because my sister took a lot of pictures on my camera. All right, so I have 6 minutes left of recording. Let's go. All right, so then you're going to submit the pipeline for execution. So here they actually have a client, and this is why I said it's easiest if your Jupyter Notebook is running inside your Kubeflow instance, because it's going to get this client and create a pipeline from this. So let's go ahead and run all of this. All right, we're just gonna step through this. If you're new to Jupyter Notebooks, you always wanna start from the very top because of weird state issues. Not a Jupyter Notebook. Jupyter Notebook is fun and exciting. All right, we're gonna just step through these. Uh-oh. Oh no. Is this not a... All right, so just as my battery was dying, I was like, hey, I forgot to install it. So let's go ahead and install it in our Jupyter Notebook here. Instead of this, we're going to do this. pip3, no, 3, up, pip3, install, KFP, we'll do quiet, and we'll comment this out. All right, let's run that. New module name pip3. Oh, maybe that's our problem. Yeah, let's restart the kernel. They're disconnected, the current shell, so I think it's that that's not finding the path from where we installed it. All right, so that actually fixed it up. We just needed to restart the kernel. So when we were doing stuff, whenever we do something in the terminal, you know, we would source the profile where we added the path and whatnot. In a Jupyter Notebook, these things are disconnected. And so that, all right. So now we can go ahead and run this and all right, so we ran this. And now we're going to do it to a container with that base image. All right, so again, this is just like the .python file that we made. We have the DSL.pipeline decorator with the name and a description, and we're going to go ahead and run this. So we created this, and we created the definition of the calc pipeline with the variables. And now we can submit this to our Kubeflow instance. So let's go ahead and run this. And we can see our experiment and run link here. So let's go ahead and click here. All right, so this is the pipeline that, all right, so it's creating the container. So when it has to first pull, I don't know that this Kubeflow instance has a TensorFlow image. It's pulling the TensorFlow image. So this can take a little while. Even though our image is built on top of that, it has to pull the base image, which can take some time. All right, and now that's done. And we can see the inputs and outputs, 7 output here. We can look at the logs. There are no logs. And here's the artifacts. All right, and then this is creating the container again. So it's probably pulling the image more than actually creating the container because our containers are really lightweight. We're only putting a few things on top, meaning that if you made changes to this and ran it again, it'd be much faster because it's not doing that pull again. It's already downloaded it. All right, and so this will go and it's going. This is all defined in your notebook here. So you can quickly iterate over some of these things, maybe a little bit faster this way. And this is great tools when you're making a new pipeline. It might not be the end all be all for a production pipeline, but it really helps when you're experimenting with new things and running like that. And you can mix and match. So if you want to experiment, let's say you have a couple of reusable containers out there, you can mix and match, because if you notice, we're specifying a pipeline here. And in this pipeline, we could actually specify using other containers that we already have built, especially if we were to look at our, let's see. Here, we could specify containers that we have actually built as reusable pipeline pieces and use them here quickly and easily, as well as experiment with new pipeline pieces. Here you can do the exact same thing, and maybe in a later video we're going to do it. We're already pushing time, and we learned a lot. So I look forward to making some more. I'm all set up to make pipelines. I actually want, one of the things that delayed this was I had some personal things go on, but also I was thinking that really when you're running Kubeflow, you should be running a image repository yourself, because you're going to be making a bunch of iterations of different images. Now you can do them on a different, like the Docker Hub registry, but I find it a lot cleaner to have your own. And a lot of companies have their own image registry, whether you use private Docker Hub or things like Harbor is probably what I'm going to use as Harbor, but I haven't set that up yet. And the reason is it's not even just not sharing your code. It's more of not polluting your namespace in some hub with these random images that do a highly specific thing. So anyways, this is the two ways here. I will commit both of these. I'm going to actually update this and get mine working. It was pretty much based off of this though, so it's not very far off. This is a slightly better way of installing it right here. And again, that goes into having the kernel loaded. But anyways, I will have those in my repository. So if you want to follow along with what I did here and see that, you're more than welcome to. And all of that code is there. I will be updating it. So in the link to this video, I will put a tag. I will tag the repository, and I will put a link to that tag in the description so that you can go ahead and check it out at that point in time. But note that the repository will continue to grow as I will add more stuff to it. If there's bugs or errors, or I find better ways of doing things, I will update these. So if you want to see the latest files, go ahead and look at the latest that are out there. If you're wanting to contribute, go ahead and make a pull request. I would love to see a contribution to that. I know that these get a little bit long, and so I'm going to try to do the best to keep them entertaining as we go along. So any commentary from me is mostly for entertainment purposes. I am not, just want to let you guys know that I'm not sitting here attacking Jupyter Notebooks. They're kind of cool. They're really fun when you get into them. So I know I said some harsher words about Jupyter Notebooks. I love Jupyter Notebooks for what they are. They're a great way to iterate and play around and see stuff happen right on the fly. And that's fantastic. And there's a spot for that. And so I don't think that Jupyter Notebooks are just the worst thing ever. My whole point is I do a lot of supporting things in production. And Jupyter Notebooks are hard to support in production. And so those are what my comments are based off of, and really where I bring my experience in. If you're just getting into machine learning, Jupyter Notebooks are great, and don't worry about anything that I said about them. If you're more seasoned, you probably already share my experience. They have this funky file layout, and they're hard to do code reviews on, and they hold funky state randomly. And This is not me flaming anything. This is not me saying it's a terrible tool, never use it. I will say that about a few tools, but not this. It is merely my opinion, as well as I'm trying to keep it a little lighthearted through an hour-long video, or I don't know exactly how long it will be after editing, but a very long video. So I just didn't want anybody to get offended because of that. We all don't like all the tools. I don't personally like Jupyter Notebooks, but it's fine if you do. And they really do serve a really great purpose. Now, that purpose can be abused. It's like Python. I think Python is really great for a very certain set of things. But a lot of times, us programmers have a tendency to like one thing and then use it for everything, and causes us problems. So I like to observe where things are good and where things fail. Like all my videos, I like to point out where you might not like to use things. I'm a big Kubernetes fan, but I believe that there's places where you don't want to use it. I'm a big Kubeflow fan. There's places you probably don't want to use it. I'm starting to think that you could run Kubeflow at home and not be as big of a pain as it might originally sounded. Don't get me wrong, it still has a lot of upkeep because of the Kubernetes cluster and then Kubeflow on top. But hopefully we can work through it and understand it together well enough where that's not too big of a deal. And then you can make your models and run with them at home. And it will be a great learning experience for your next job. And it also will provide you a great experience while training your own models. That's it. Let's be done. All right, I'm going to be done for today. I know that we covered a lot. If you have any questions, things weren't clear, be sure to leave a comment, because I will be doing more Kubeflow Pipelines videos, and I'll make sure to cover any questions in the comments in the next Kubeflow Pipeline video. I'm not promising you'll get one in a week, but I'll try to make sure to cover anything that was unclear, because I know that we covered a lot. If you are wanting to see anything specific, again, please just let me know in the comments. All right, so that was your basic introduction into creating your own Kubeflow pipeline. And that's going to be it for me today. I put a lot of work into breaking down Kubeflow pipelines. I hope that you all enjoyed it, and I look forward to seeing you in our next video. Maybe it will be about Kubeflow pipelines. We have a lot to cover here. Maybe it will be something else about Kubernetes. Maybe it'll be about Python. Leave me a comment down below what you're wanting to see. Do you want to see some algorithms? Do you want to see more Kubeflow? Do you want to see more Kubernetes? Do you want to see Rust? I want to do more Rust. That's one of my things I'm learning this year is Rust. I say that every year, but this year is the year. I've actually written some stuff in Rust, but yeah. Anyhow, I will see you guys next time. If you didn't like this video, I'm gonna need you to go ahead and hit that subscribe button, stick around and watch the next videos and see if they get any better for science.